I don't have any x value. So what I will do, I'll keep x as it is and I'm going to substitute rest of the values. The values of y for any given values of x between x0 to xn is called interpolation. Forward in the sense what? I'm going to consider the second number, and from the second number I'm going to subtract first number. Hello to all, a warm welcome to my new session on solving simultaneous linear equation. I'm your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So dear student, once again in my today's session, I'm going to deal with Lagrange's interpolation formula. Before that, let me to recall the topic what I have discussed in my previous session. So dear student, in my previous session I started with Gauss-Jordan elimination method. Along with that I have discussed Lagrange's interpolation formula and how this Gauss-Jordan elimination method is going to work, in the sense whatever the system of equation I'm going to have, that should be written in the form of augmented matrix. After that, except diagonal elements, I want to make all the elements 0. For example, say I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Except these diagonal elements, I want to make rest of the elements 0. So this is 0, this one 0, this one 0, this one 0, and this one 0. Except diagonal elements, I want to make all the elements 0. Along with that, I have discussed Lagrange's interpolation formula. And what is the formula? I have y equal to, and here I am going to have the y0. So x is common. So it starts from x1, x minus x2 up to x minus xn. And here x0 minus x1, x0 minus x2 up to x0 minus xn plus. Now I am going to consider y1. So what I want to do, I want to leave x0. So I'll start from x minus x0, x minus x2, because here it is my y1. So I'm going to skip x1 and up to x minus xn. And here x1 minus x0, x1 minus x2 up to x1 minus xn, and it's going to continue up to yn. So this is the Lagrange's interpolation formula. Now in my today's session, once again I'm going to deal with few example problem under Lagrange's interpolation formula. Along with that, I'm going to deal with Newton's Gregory forward interpolation formula. Now, dear student, let me to solve one more example problem. That is, I have if y1 equal to 3, y of 3 equal to 9, y of 4 equal to 30, y of 6 equal to 132. Find Lagrange's interpolation formula. That is, I want to find Lagrange's interpolation polynomial. So here I am not going to have any x value. If I don't have any x value, then what I want to do? I want to keep x as it is and I want to find the interpolation formula or interpolation polynomial. Now, let me to solve this problem. So, what I want to do, see here, this y is 3. Okay, so it is y naught equal to 3. Then what about this 1? There is nothing but x naught. So, x naught is 1 and y naught is 3. Now, x1 is 3 and y1 is 3. Now, x2 is 4, y2 is 30. Now, x3 is 6 and y3 is 132. And I want to find out f of x. So, what is f of x here? That is nothing but the polynomial equation. I want to find polynomial equation. Now, I have the Lagrange's interpolation formula. Now, I have y0, y1, y2 and y3. Okay, based on my table of content, I'm going to construct the formula. Now, see here, I don't have any x value. So what I will do, I'll keep x as it is and I'm going to substitute rest of the values. And after substituting rest of the values, my equation looks like this. Okay, now what I want to do, I want to simplify this equation or I want to simplify this formula. Okay, fine. After simplifying this formula, I'm going to get this answer. Okay, so here if I consider this one, I have x minus 3, x minus 4, x minus 6 plus it is 2 divided by 9. Then here it is minus 5 and here it is 22 by 5. And if I consider the above equation, that remains as it is. Okay, now what I will do, I'm going to take 1 by x outside because I'm going to find the LCM. Okay, after taking LCM, what I will do, I'm going to take 1 by 10 outside. Now, see, I have x minus 3, x minus 4 and x minus 6. Okay, now see here, it is 15, x minus 1, x minus 4 and x minus 6. Once again, here also I have 50, that is minus 50, x minus 1, x minus 3 and x minus 6. Okay, now what I want to do, I want to simplify this one. And to simplify this one, I'm going to have the formula. I'm going to have the formula that is x minus a, x minus b and x minus 3. So if I expand this one, I'll get x cube minus x square, a plus b plus c plus x of ab plus bc plus ca minus abc. Okay, and I'm going to apply the formula. So after applying the formula, after simplifying this one, I'll get x cube minus 13x square plus 54x minus 72. And what is common here? 1 by 10 is common, so I'll take outside. Now here 15 of x cube minus 11x square plus 34x minus 24 minus 50 x cube minus 10x square plus 27 x minus 18 plus 44 x cube minus 8x square plus 19x minus 12. Now, what is common here? That is 1 by 10. Okay, now see here. I have x cube, x cube, x cube and x cube. Okay, so here it is 15x cube minus 50x cube plus 44x cube. I'll get the answer 8x square. Now see here, I have 13x square. Here I have 10x square. Here I have 8x square. And when I multiply with 44, okay, I'll get the answer minus 4x square. Now see here, I have 54x, 34x. I want to multiply this one, and I want to multiply this one, and I want to multiply 44 into 19x. So I'll get the answer minus 58x. Now see here, I have 72, here minus 24, here 18, and here it is minus 12. I'm going to get the answer plus 84. Okay, now this is the required polynomial. So dear student, this is the answer for this question. So the required polynomial is f of x equal to 1 by 5, that is 4x cube minus 2x square minus 29x plus 42, because see here, 2 5s are, 2 4s are, 2 2s are, 2 2s are, and it is 18, 2 9s are, 2 4s are, and 2 2s are. So this is the required polynomial. So dear student, in my last session, I started with what is Lagrange's interpolation formula. Along with that, I have discussed few solved example. And from the examination point of view, this topic is very, very important, and even you can expect one sure question. So dear student, along with this, I am going to explain another topic, that is interpolation. So dear student, interpolation is very, very important concept. Now let me to consider this statement, that is if y0, y1, y2 and up to yn be a set of values and unknown function. So what is y0, y1, y2 up to yn is nothing but the unknown function, then y can be written as f of x, or it is nothing but x and corresponding to the values of. So here f of x ranges from x0, x1, x2 up to xn. The process of finding, there is nothing but the estimating the values of y for any given values of x between x0 to xn is called interpolation. So dear student, here I am going to have the y value, that is nothing but y0 to yn. Those are the unknown values. Along with that, I am going to have some corresponding value, that is x equal to x0, x1, x2 up to xn. So I can able to write y equal to f of x. So this x ranges from x0 to xn. By using these two values, I can able to estimate the values, and that is known as interpolation. So dear student, now let me to discuss the two types of interpolation formula, that is Newton-Gregory forward interpolation formula as well as Newton-Gregory backward interpolation formula. First, let me to explain Newton-Gregory forward interpolation formula. So dear student, Here I'm going to have the values of y equal to f of x. Okay, now y equal to f of x, and it ranges from y equal to y naught plus RH. So what is R? That is nothing but the real number, and H is nothing but the height or the distance. That is YR equal to f of x naught plus RH is approximately calculated by, so here YR equal to y naught plus R delta y naught. Okay, so it is delta y naught plus R of R minus 1 2 factorial delta square y naught, and it's going to continue. Anyway, dear student, I will tell you how to find out delta y naught, how to find out delta square y naught, and how to find out delta cube y naught. So dear student, this is the formula used to calculate Newton-Gregory forward interpolation, where R is nothing but the real number. And another formula I have, that is Newton-Gregory backward interpolation formula. And see the difference here. Same formula you have to remember. Okay, if it is forward, then I'm going to have the delta, and here it is R minus 1, R minus 2, R minus 3. Okay, if it is backward, see, instead of R minus 1, I have R plus 1, R plus 2, R plus 3, and so on. And it is inverse delta. See, I'm going to have the inverse delta because it is backward interpolation, and the formula is same, but what are the two things you have to remember? In backward interpolation, I'm going to have inverse delta and plus symbol, whereas in forward, delta along with minus symbol. So what is the formula? Yn plus R delta Yn. Here I'm going to consider Yn, but if I consider forward, it is Y naught. In the sense, I'm going to start from the beginning. So that is Y naught. If I consider forward, it is Y naught, and if I consider backward, that is the end, then it is Yn. So it is Yn R delta Yn plus R of R plus 1 2 factorial inverse delta square Yn, and it's going to continue up to n factorial, where R is nothing but the real number. Now, dear student, by using these two formulas, let me to solve some example. So, dear student, I'm going to have the table, that is find y of 1.4 given the data, and I have the table. Okay, I have the table. Now, I know that f of x equal to y. So here y of 1.4 is nothing but x equal to 1.4. Okay, now since the value x is near to 1, okay, since the given x value, that is 1.4, which is nearer to 1, so it is forward interpolation. So it is nearer to 1, so it is forward interpolation. In the sense, I want to apply forward interpolation formula, that is NFIF. So to apply forward interpolation formula, what I want to do? I want to construct the table. So dear student, from the previous data, that is from the previous table. So this is my actual table. From this, once again, I'm going to construct the table. So I have x, y, delta square, delta cube, delta 4y, etc. So here y naught is 1 and x naught is 10. Now what I will do, I'm going to write x value and y value as it is. So I'll write 1, 2, 3, 4, 5. That is y naught is 10, 26, 58, 112 and 194. Now see here, I want to find the difference in order to get delta. So here delta y is nothing but 26 minus 10, it is 16. Okay, fine. Now 58 minus 26, it is 34. Now 112 minus 58, it is 54, and 194 minus 112, it is 82. Okay, I'm going to subtract 26. In the sense, I'm going to subtract 10 from 26. So 26 minus 10, it is 16. So this is the way I'm going to find delta. Now I want to find delta square. Okay, to find out delta square, I'm going to consider delta y. Okay, now I have 32. So 32 minus 16. So forward in the sense what? I'm going to consider the second number, and from the second number, I'm going to subtract first number. So it is 32 minus 16. Once again, it is 16. Now 54 minus 32, it is 22. 82 minus 54, it is 28. Now I want to find delta cube. To find delta cube, I'm going to consider delta square. So here 22 minus 16, it is 6. Now 28 minus 22, it is 6. Now to find out delta 4, I'm going to consider delta cube. So 6 minus 6, I'm going to get the answer 0. So dear student, this is the way I'm going to construct the table. Now what I want to do, I want to write Newton forward interpolation formula. So YR equal to Y naught plus R delta Y naught plus R into R minus 1 divided by 2 factorial delta square y naught plus R into R minus 1 into R minus 2 divided by 3 factorial delta cube y naught, and it's going to continue. And here I'm not going to consider delta 4y because it is 0. And when I multiplied with 0, I'm going to get the answer 0. So I'm going to stop the formula here itself. Now, what are the things I want to find out? I got y naught, I have delta y naught, and I have delta square y naught, and I have delta cube y naught. But what I want to find here, I want to find out r. To find out r, I'm going to have the formula. So r equal to x minus x naught divided by h. So r is equal to x minus x naught by h. So what is x here? A point at which y is required. In the question they mentioned it is 1.4. Then what about y naught? That's nothing but the starting point. Okay, initial point. So what is the initial point? If I consider this table, it is 1. Now h is nothing but the common interval length. Okay, so what is common interval length? So here the gap between two numbers. So 1, 2, 3, 4, 5, it is 1. So it is 1. Okay, then R equal to 1.4 minus 1 divided by 1. So it is 0.4. Okay, now see here. I got delta y naught 16, delta square y naught 16 and delta cube y naught it is 6. And I'm going to substitute all these values in the formula. Okay, after substituting formula and after simplifying the formula, I'm going to get the answer y of 1.4 equal to 14.864. And what about r factorial? That's nothing but 2 factorial, that is 2 into 1. If it is 3 factorial, 3 into 2 into 1. So here I got 6 and here I got 2. So here see y naught. So y naught is 10 plus r into delta y naught. R is how much? It is 0.4 into 16 plus R 0.4 into R minus 1. So 0.1 divided by 2 and delta square y naught, it is 16 plus. See, like this I'm going to substitute. After simplifying this, I'll get the answer y of 1.4 equal to 14.864. Anyway, dear student, in my today's session, I started with what is interpolation and what are the two kinds of interpolation formula we have. That is Newton's Gregory forward interpolation formula as well as backward interpolation formula. Anyway, dear student, let's meet in the next session with the concept that is Newton's forward interpolation formula and Newton's backward interpolation formula. Until that, keep watching and keep learning. Thank you.